this way. You are no more interested in sending the object this way or dropping the object, or you go to the height above and you send. We are now sending the object this way. If you are sending the object this way, let us look at examples of objects that the people will send this way in sports, to be precise, because there are two key things here. You should know examples in sport. You should know the examples of the projectile in warfare, that when people are fighting war. Let us look at the sports. Let us look at sports. The examples of projectile you can use in sport can be the javelin that they send. If you have been in sport environment, the discourse that they will do, the discourse. Even when you kick a football, when you kick, the football is going at an angle. That means football can also be an example of that. When you kick that, it can be an example of that. Etc., etc. You can now think of many examples of objects in sports that people send this way. Now let us go to war. When people are fighting warfare. Examples of projectile people will use in warfare here will be a stone that will move from a catapult. Then rubber fact the way they can get. The moment you put a stone in that particular catapult you release, that one is going at an angle. Whatever way you look at it, you make it this way, it is going at an angle. So that means a stone from a catapult is an example of a projectile. Stone from a catapult. Catapult is an example of a projectile. The other one will be a bullet from a gun. Bullet from a gun. Bullet from a gun. When somebody fires a gun, the bullet moves at an angle. The bullet will go at a particular angle. So you must be able in the exams. If in the exams you are able to recall examples of objects people will use in sport that are classified as projectile, you are also able to look at objects people will use that are classified as where in sport and warfare you have done 10% of the exercise here. We now move. Now if we move further to what? We say the object is thrown from the particular surface or on the ground at an angle here. You now send the object this way. You are not sending it vertically, you are sending it this way. That is why you are seeing the curve. And the object is moving at an angle theta. Now there are two axes here. The one at this point we call that the initial velocity axis. That is the initial velocity and the unit is in meter per second. And this axis become the time axis, which is in second. So if that is the case, the path that is traveled by the projectile, the path that is traveled by the projectile, that means the route this object is taking, when you say that particular line or route that object takes is known as trajectory. Trajectory. So when you want to define the trajectory, you say trajectory is the path or the road or the route taken by a projectile. Now, initially, if we try to draw a line that is tangential, a tangent is a line that touches a curve or a circle without entry. So if I draw a line near tangent, I will move until I escape from the curve here. So the velocity is now escaping from that particular curve. Now that velocity has to be resolved. But in further mathematics, anytime you resolve something horizontally, you call that cos of the component. When you resolve vertically, it becomes sine. So we say vertical component. Anytime we are interested in the vertical component, we make use of sine theta. When we are interested in horizontal component, we make use of cos theta. That is what I mean. Now, if that is the case, it takes us to this expression here. Again, if you look at the top of the curve here, that is the highest point. And the highest point reached by the object, final velocity is equal to 0 at that point. And that particular point is what we call maximum height from the ground. From here to here is maximum height, h max. When the object falls again on the ground, when you send the object this way, the moment the object falls on the ground, that object will also move. Except when you are in swampy areas. But if not, when you send the object this way, when that object falls on the ground, the object has to move, whatever way you look at it. And when it is now moving on the ground, the distance it takes on the ground is known as horizontal range. Now let us go to basic equations. what are the basic equations we want to write now? We know very well that there is one that says v equals u plus at. Now let us change the parameters here. V is becoming u, a is minus g. Why? Because the object is going upwards. Have in mind, even when you are sending the object this way, it is going upwards. So if that is the case, a becomes minus g anytime the object is moving away from the ground. And then we have small t here. Now at the highest point here, v is equal to 0. At the highest point, v is equal to 0. Highest point. So v is equal to 0. U is equal to u sine theta. Why? Because the object is going upward, and if it is going upward vertically, at the vertical component, it will be sine of that velocity. It is sine theta. If you are on the horizontal, it is cos. But since we are in the vertical direction, it is u sine theta. The u attaches to sine theta because we are resolving u vertically. Minus gt here. If I want to get minus gt positive, I will take it to the left. If I take minus gt to the left, become positive gt equals negative cos, it become positive. You have u sine theta. When you want to get small t, g, when you want to get small t, divide both sides by g. If you are interested in small t, divide that by g. So small t becomes u sine theta divided by g. That means it's the time taken by the object to go to the highest point. The time taken by the object to go to the highest point from here to the highest point. And I said the time taken to go to the highest point is equal to the time taken to fall to the ground. So if from here to the highest point is small t, from the highest point to the ground again is small t. If you now combine this time in air, that means the time required by the object to move to the highest point and back to the ground, you call that time of flight, if you can recall. And that time of flight we combine from here to here and from here to here. The time of flight combines from here to here small t plus from here to here small t. So capital T becomes small t plus small t is 2 small t. Now you put the value of small t. Small t is here. Wherever you see small t, you put u sine theta divided by g. So this becomes, the 2 is here, but the small t is u sine theta divided by g. U sine theta divided by g. So that formula is the formula we use to get the time of flight. Anytime you are required to get time of flight, that means the time taken by the object to go to the highest point and back to the ground. Let us now go to how can you get the maximum height. What will be the formula for the highest height attained when you throw an object at a height, at an angle? Anytime an object is at an angle, what will be the formula for the height? So if we want to make use of that, we recall this equation that says v square equals u square, v square equals u square plus 2as. But we are changing parameters here. We have u square, the plus 2, a changes to minus g anytime the object is moving upward, and s changes to h. The s always changes to h. So if that is the case, we have v square equals u square plus times minus is minus 2 times g times h is 2gh. Now we have certain things. When the object is at the highest point, there is no final velocity. That even came in our exam when we took the last exam. Anytime the object is at the highest point and you are asked to calculate the final velocity, tell the person that there is no final velocity when it is at the highest point. So v is equal to 0, it becomes 0 square equals u still in the vertical direction. When you are in the vertical direction, it is sine theta. So this u is u sine theta. Why sine theta? Because vertical direction. But because of the square here, we square everything there. Minus 2gh. 0 square is same as 0 equals, the square is for the u and sine theta. So u raised to the power 2 is u square. But when you say sine theta square, it is the square will always come to the sine and not the angle, the theta. So anytime you say either sine or cos or tan, when you square that, the square comes to the sine. So it becomes sine square. The theta will not have any square. Minus 2gh. Now when you want to make minus 2gh positive, you transfer it to the left. When minus 2gh crosses here, become positive 2gh. And that is becoming u square sine square theta. But what we are interested in is to find h, maximum height. So in order to get the maximum height, you divide both sides by 2g. If I divide here by 2g, I divide here by 2g, the 2g cancels here. What is left is h equals u square sine square theta divided by 2g. So anytime you are asked to get the maximum height when the object is projected at an angle, the formula is u square sine square theta divided by 2g. We are done with that case. Let us now say the object is now on the ground. You projected it initially at an angle, but the object finally is on the ground, and the object is moving now on the ground. Let us now look at the equation that you write. So if we are looking at when the object is now on the ground, you recall one of the equations. The equation says s equals ut plus half at square. Let us now change the parameters here. What are the parameters that will change? S becomes r now. Instead of h, the object is no more at height, it is on the ground. So the s, the distance covered, is now on the horizontal, and that is horizontal range. Equals u small t plus half. The a changes to g, and we have small t square. Now let us see here. We want to change some parameters again. What are the things we change? R equals u, small t is changed to capital T. Small t change to capital T. How? When you are covering this distance from here to here, it is combined into small t. That means from here to here small t, from here to here small t. It's the same as from here to here, which is the range now. So if you are interested in the whole range, instead of small t, it becomes capital T. That means you are combining this small t and this small t. When this small t and this small t, this part of the curve and this part of the curve be combined, they will give you this line. Then we have plus half. G becomes 0. Why? Because there is no gravity. There is no gravity on the ground. No gravity. It is acceleration that we have. We have t square here. So the range becomes ut. Half times 0 times t square, everything is 0. 0 plus ut is ut. So the range is equal to ut, capital T. If that is the case, let us substitute. We have range equals u is here, and u is now on the horizontal direction. The object is in the horizontal direction, this way. Object is in the horizontal direction, so it becomes cos of that. When you are in the horizontal direction, it becomes cos. So that is u cos theta. The u here becomes u cos theta because the object is now in the horizontal direction. And we have capital T. The formula we stated for capital T few minutes ago was 2u sine theta divided by g. That was time of flight. So if that is the case, I will take that up here and I will write the range equals. If I now write the range, I will have u times u here. This u times this u become u square. I will move. This 2 is what I have written here. This sine theta is what I have written here. This cos theta is what I have transferred. Everything has to be divided by g, this g that you see. In further mathematics, there is an identity in further mathematics which says anytime you see 2 sine theta cos theta, you put sine 2 theta. So the identity you can recall if you have not done is that 2 sine theta cos theta is always equated to sine 2 theta. Sine 2 theta. So wherever you see 2 sine theta cos theta, you put sine 2 theta. I will have r square. R now equals u square. Instead of we write 2 sine theta cos theta, we put sine 2 theta. So that becomes sine 2 theta. Has to be divided by g. So that is the formula for the horizontal distance covered. That horizontal distance